Hi, so I'm going to remind you how to find the solution of a system with a quadratic and a linear equation. So as you may remember, there are two ways to find the solution. You can graph both equations and find the point of intersection, or you can just solve it algebraically. So I'm going to walk you through both ways in this video. In this problem, there are two equations given to us. The quadratic function is represented by f of x, and the linear function is represented by g of x. I know that the first equation is a quadratic because it's in the form y equals ax squared plus bx plus c, and I know that the second equation is linear because it's in the form y equals mx plus b. Now I'm going to make a table for each equation so I have the values for graphing. I plug the first equation, 2x squared minus 8x plus 3, into y equals on my graphing calculator. You can easily do this on Desmos, which is an online graphing calculator. I then looked at the table and I copied down the values in both columns. Now I'm making the table for the linear equation, g of x equals negative 2x plus 3. I can use my graphing calculator again to copy down the values in the table for this equation. Because it's a linear equation, the slope stays constant. This means that for this particular equation, every time the x value goes up by 1, the g of x value decreases by 2. Negative 2 is a slope, so it makes sense that we are seeing this decrease of 2. Sorry, I accidentally wrote f of x instead of g of x on this table, so I hope that doesn't confuse you. Now it's time to graph both of these equations. I'm going to first graph f of x using the color blue. The first coordinate I wrote on the table is negative 1, 13, so I'm going to plot that, and then go back to my table for my next coordinate, 0, 3, and plot that, until I finally finish plotting all my values, resulting in my coordinates being in the shape of a U. I connected all of the points as best as I could, I added arrows, and I labeled it with its equation. Now my parabola is complete, and I can move on to graphing the linear equation. Now it's time for me to graph g of x using the color red. The first coordinate I wrote on the table is negative 5, 13, so I'm going to graph that first. You can also graph linear equations by starting at the y-intercept and moving according to the slope, but I decided it would be easier for me to just use the coordinates from my table. After I was done with plotting the points, I noticed that they all lined up in a straight line, which is how a linear equation should look like on a graph. I connected the points with a straight line, added arrows, and labeled it with its equation. Now I'm officially done with plotting the points from both equations on the graph. I have to find the solutions now, which are the points of intersection. It looks like that there are two solutions, 0, 3, and 3, negative 1. Even though 0, 3, and 3, negative 1 are the solutions to this problem, I have to pay attention to what the problem is asking for. It says that I have to find all of the values of x that would satisfy the equation f of x equals g of x, and that is another way of saying that I need to list the x values of both solutions as my answer. The x value of the first point of intersection, 0, 3, is 0, so this means I would write x equals 0 as one of my answers. The x value of the second point of intersection, 3, negative 1, is 3, so I'm writing x equals 3 for my second answer. This is how your work should look like after solving a system with a quadratic and a linear equation graphically. Some problems may ask for just the x values like this one, but others may ask for the coordinates of the solution, so just pay attention to what the problem says. Now I'm going to solve the same problem algebraically. First, I'm going to set up both equations as equal to each other so I can find the x values. This means that the equation will be 2x squared minus 8x plus 3, which is f of x, equals negative 2x plus 3, which is g of x. I'm going to now make one of the sides of the equation equal to 0 so I can factor the other side. To do this, I add 2x and subtract 3 on both sides of the equation. The new equation is 2x squared minus 6x equals 0. There are many ways I can solve this, but first I'm going to see if I can pull out a common factor from the terms on the left side of the equation. The greatest common factor of 2x squared and negative 6x is 2x. This means that for the next step, I'm going to write 2x outside of the parentheses. To find what's inside the parentheses, I have to divide each term by 2x. First, 2x squared divided by 2x is just x, so I know that x is the first term in the parentheses. Negative 6 divided by 2x is negative 3, so I know that negative 3 must be the second term in the parentheses. It's still equal to 0 because before we divided both sides by 2x, and 0 divided by 2x is just 0. We can now clearly see that we have two factors that are being multiplied to equal 0. The first factor is 2x, and the second factor is x minus 3. Since they are being multiplied to equal 0, this means that one or both of these expressions must be equal to 0. This is an example of the zero product property. I'm now going to set up two equations, 2x equals 0 and x minus 3 equals 0, because again, one or both of these expressions must be equal to 0. This means that we will probably get two x values as our answer. To solve the first equation, 2x equals 0, I divided both sides by 2 to isolate x. 0 divided by 2 is just 0, so I got x equals 0 for this equation, which is one of my answers. Now I have to solve the second equation, x minus 3 equals 0. I added 3 onto both sides to get that x equals 3, which is my second answer. This is what my work looks like after solving this system algebraically. If I go back to how I solved it graphically, I got the same answers, x equals 0 and x equals 3, which is expected. Also, keep in mind that not all equations like this one can be solved in the same way. You may have to use the quadratic formula instead of just pulling out a common factor. In some cases, the algebraic method may be faster, but you can solve it graphically as well and get the same solution.